Welcome to this third webinar from AIML Community Nepal. Today we have Siddhi Kiran Bajracharya from Leapfrog. He will be sharing his work or idea regarding multi-object tracker evaluation using CLEAR MOT metrics. Right. Before jumping into his presentation, I'll try to take around 5 or 10 minutes to discuss more about the community and the vision and what we are trying to do. And again, I will repeat that if you are comfortable, please free to put your camera on, right? So that we can know each other, we can see each other, and we can start to feel we are connected, though we are virtually doing this webinar. And second thing is that based on the feedback from you guys, what we are planning to do is after whole presentation at end, instead of we taking the questions, we will try you to put your question yourself by keeping audio on and camera on if possible, and ask whatever you want for the presenter. We are trying to do. But in between, if you have any concern or question, you can write in chat. I'll pick that and I'll ask Siddhi, right? And we are planning to break this in a whole presentation. There will be 3 breaks, right? Where we'll take your questions and we'll pass it to Siddhi and he'll respond to you. Before moving forward, okay, now I'll take some time to discuss about the community, what we are trying to do, and what is the value proposition of AIML community. For me, the basic mantra of this AIML community is to learn, to connect, right, to help each other, right, and to get a job, which means to open opportunity to land your dream job or land your good network or something like that, right? And if you speak in terms of startup, then it is the value proposition. And to learn, to get connected, right, and to help each other, we need to communicate, right? And in this session, from the very beginning, I'm asking our community member to communicate, to put your thought on, right? And there might be things where to put your thought, right? For that, we have Slack channel, right? What we are trying to do is right now we have Slack to get connected, and in Slack we have different channels, and the different channels have their different objective to solve, and few of them I'd like to discuss, right? And I'll request to community member to use that, right? Because for 3 or 4 weeks I have noticed that is quite inactive, right? But to grow this community, right, to make it more strong, we need to get connected, we need to discuss our idea, we need to put our thought. It will help to groom new people, right? And it will also help for senior people to validate their idea or thought. And there is here you can see there are a few channels. One of the very useful channel would be ask for help, and in this channel you can go and ask any sort of help. It can be technical, it can be theoretical, it can be regarding your studies, it can be regarding your foundation and anything, right? And introduction is something very general. Put your introduction over here, right? And research is something, if you find any interesting research paper or interesting talk regarding the research or interesting way to solve the problem in industry or architecture or something like that, just go and put those sort of things over research, right? And we can start to think about those sort of things. And what will be the benefit? It's like there might be so many research going on right now, right? But are they solving our real problem, the localized problem, what we are facing every day in Nepal? Most of the solution, no. Why? Because they are not trained on our data and they are not feasible in our country, right? If we put those sort of challenges or problem over there, we might start to brainstorm, right? And we might start to come up with some sort of localized problem which can solve the problem in our country, local problem through the AI and AML, right? And that will start to create more opportunity for us as engineers. If you go to the most of the company right now in Nepal, AI AML is like an experimental department. People doesn't know what to do with that, because we ourselves who are working in this field, we haven't tried to solve most of the problem out there using our knowledge and the technique, right? So let us start to use those sort of channel And another thing is that if you want to present anything about your idea, about your solution, or if you want to give talk regarding anything, please reach out to the core member. You can find the name of the core member in website, right? Or you can reach out to me in Slack. I'll be more than happy to connect with you, talk with you, and try to arrange something, right? And another thing is that if you guys are willing to be a part of the community as a core member, right, just reach out to us, right? And we'll talk, right? And we'll think how we can start to get together, because as we expand the core member means there will be more responsibility for management. And for right now, due to with the available resources, could it be possible to take that much people or not? We'll start to make a plan, right? We'll start to break down different things, but for that you need to communicate, you need to discuss, you need to reach out to us. Yes. And that is what I was thinking to present from the community side. Now, as a second part of this webinar, we have Siddhi from Leapfrog, very good engineer. He has very good experience from different companies from Nepal, like Soft. And today he will be presenting about multi-object tracker evaluation and the problem and the solution. And let us welcome to Siddhi. Siddhi, now it's your floor. You can share your screen and you can present your idea.
Hi everyone. Let me start with my brief introduction. Thank you Siddhi for reaching out to me and the AIML community of Nepal. So
Siddhi, if you are sharing your screen, you cannot see.
Okay, I have not shared my screen.
Okay, I think it will be good to start with sharing your screen.
Can you see my screen?
Yes, we can.
Okay, so I am Siddhi Kiran Bajracharya, and I have been working as ML engineer in Leapfrog for a few months. I would like to thank Siddhi and AIML community for giving me a platform to show some of my works that I've been doing on the multi-object tracking. Let me start with a few agendas. The things that we'll be covering are in the screen right now. So we'll be introducing multiple object tracking briefly, and types of errors in multiple object tracking and few challenges. And we'll also be going through some of the evaluations metrics that I used previously and that I'm proposing with the CLEAR MOT metrics. And we'll also be getting some hands-on experience with how MOT evaluation is done. The things that are not covered in this are the in-depth discussions about the algorithms, such as the object detectors and the trackers, and the other evaluation metrics, and their in-depth discussions about their algorithms. I'll not be focusing on how good the models are. I'll just be focusing on the evaluation metrics. And of course, there are other evaluation metrics that have come up after the CLEAR MOT. I'll only be introducing them briefly and not covering them thoroughly. So let me start with the introduction to multiple object trackers. So as you can see on the right side of the screen, it is pretty hectic, but if you can see closely, there are these bounding boxes over few people, like a lot of people, right? And they're assigning numbers to each one of the bounding boxes. And if you see more closely, you can see that each person is only assigned to a same number, right? For example, this is assigned 8 throughout all the frames. So the multiple object tracker basically consists of two parts: the object detection, and this is the same type of object detection models that we are familiar with, like YOLO and MobileNet and all the things like that. The other thing is the deep sort. Other thing is the tracker model, which is as the name suggests, it's basically used to track the same person throughout the screen, like the thing is happening on the right side of my screen, right? So there are a lot of trackers, and for this demo, I'll be using YOLO, sorry, YOLO object detector and the deep search tracker. Of course, you can use other trackers as well. Talking about the applications areas of the MOT, I think the most of the heavy investments come from the automobile companies that are really focused into self-driving cars, right? So yeah, and this video clip on the right side of my screen shows what an actual the self-driving car might see, right? And there are lots of other application areas such as road traffic analysis. This is some this is a kind of similar thing that we are currently doing at Leapfrog for one of our clients. Right, some lesser known or some lesser applied things would be surveillance system and for sports analysis systems, right? So you can see some of the applications and there some brief details in the left hand side of the screen. Talking about the MOT, it has its own challenges, right? We don't see most people doing the evaluations for MOT because there are a few challenges that come with it. For example, occlusions. So on the left side, you can see that there are a lot of cars, right? But the object detection model is only focused on 2 cars. This is because the model is not properly trained to identify these cars that are occluded, right? These cars are occluded and the model cannot identify them properly. So in tracking, right, or in object detection or classification, identification, another problem would be people in the same uniform. It is very difficult to uh, track them because they have the same uniform and they look very similar. So if I'm using multiple object tracker model, there are chances that the model will be confused between these 2 police officers, right? So these are just some of the challenges that are faced in the multiple object tracking models. So another challenge that I would like to discuss is that the cascading problem, right? So you can see on the right hand side, on the left hand side of my screen, this is a person that is labeled 24. So yeah, but on the other frame, the person is not on the bounding boxes, right? Because the model failed to detect it as a person, right? So on the next frame, the tracker loses track of this person and then it assigns a different ID to that person. So if this happens, then the person on this side is not tracked properly. For instance, the person on the bicycle is being tracked correctly, but the person that is walking from rear is not tracked properly. So this kind of problem is what I like to refer as the cascading problem in the multiple object tracking problem. Not only there are the technical side of the MOT problems, but there are also some research gaps that I would like to discuss. So a lot of people like to build their own multiple object tracking models, but when it comes to the evaluation, we get confused a lot because we don't see these evaluations going on in most of the online resources. And some research challenges that I stumbled onto were like there is no common metrics for evaluation that everyone agrees on. So even in the case of CLEAR MOT evaluation metrics that I'm currently discussing on, so most of the people are some people like the MOT, some people like the CLEAR MOT evaluation metrics, while some other people do not like it and they prefer to go with some other kind of metrics. There's also very limited work done in the multiple object tracker evaluation field. And if you just see, there are papers coming out recently that kind of tackle these problems. And the other problem that I would like to discuss is that it is very difficult to get the ground truths for the multiple object tracking, right? Since we have to do the labeling for the whole video, it is very difficult to get the ground truths and it's a very big investment. So yeah, most people do not bother with the evaluation, they just go and use the pre-existing model without any, with very few tuning, and just I guess just visually evaluating them, which I think is good for like few videos, but in actual production, and when you're actually talking with the clients, and when you're actually communicating with the clients, they do not want to go manually through each of the videos. They just want to see one metric that says, this is the accuracy that the our tracker is giving, right? So
Yeah,
when I was
Siddhi, I would like to stop you over here, right?
okay.
And this is our first part of the presentation, right? And generally we discuss about what is the problem and what we are trying to solve. Do we have any question right now? Does anybody want to go and raise any concern? You are free to use chat, or you can use your microphone to ask question. Seems like there is no one. I have one question. When people have same uniform, right? You told that there might be a problem of tracking the people, right? But my concern is that, but the people will have different texture, means their shape, size might be the different, right? Why only with the uniform is harder to detect?
I didn't quite get you, and like.
Let us imagine you and me, right? You and me, if we are wearing the same uniform, right? Though it's like you might be more muscular than me, right? We have the different shape and size, and we have different texture or body shape, right? Which might be information to detect, though we are in the same uniform, right? But why the algorithm is confused in those sort of scenario?
So yeah, the major problem comes from the detection algorithm, right? So and what happens is that in real life example, the camera might not be that in a very convenient position, and it might be really difficult for the models to find out exactly what how exactly the person looks. So I think that might be a problem why this problem only occurs in people wearing same uniforms. So just don't just imagine like there are only two people, right? For instance, there could be a lot of people with on this uniform, right? So a lot of school children's, right? There may be a chance that two people might look different, but there might be a even greater chance that most of the students in a same class might look very similar to the camera and to the model, right? So that's why it's more challenging for the model to just track those individuals on their frames.
Okay, thank you, Siddhi. Anybody, any question? We're moving to second part. Okay, I think Siddhi, you can go ahead.
So when I started with the multiple object tracking, I just did some research on the multiple object tracking. I downloaded few. I went through some Git repositories, and they were only focused on the object tracking, and I didn't know like there was some separate research done for the evaluation of the tracking. So my basic approach was to calculate the intersection over unions for each frame, right? So the intersection for union is one of the popular metrics used to evaluate object detection algorithms. So you can see on the right hand side, the IOU is the area of overlap by the area of the union. And this could be the ground truth. Yeah, the overlap between the ground truth and the prediction to the ratio of overlap between the ground truth to the prediction and to the area of the union of the ground truth and the predictions, right? So this is the IOU that I'm talking about. And so my initial idea was to calculate the IOU for each frame and just average them or aggregate them through some means, right? And then just calculate the precision recall and F1 scores. This is working quite well for initial evaluation of these trackers, but there was some serious drawbacks, right? Because these things, my trivial approach was only focusing on the object detector, but not the tracking. So my object detector was working great, right? But my tracker might not be working that better, right? So there was also confusion on how to aggregate these data, right? What was it implying? And it was very difficult to communicate to the client that this precision means this, and a lot of things like that. But the client just wants the person that I'm reporting this to just wants simple metrics that just says accuracy, right? The business people do not know what the precision recall and F1 score might refer to. They just want to hear what is the accuracy of the model, and I get that quite a lot from the people that only understand business, right? So that was a challenge for this triple approach. um, Before jumping into the clear mod metrics, I would also like to discuss some of the errors that might be occurring on the multiple object trackers, which I did not anticipate when I was just starting out with the multiple object trackings. So after some research, I discovered that there are three major types of errors that happens in the multiple object tracking. The one is the detection errors. So the detection error happens the predict when the model when the model predicts something that isn't there, right? So for in this instance, the model predicts that here is some object, but the object is right here, right? So this is a miss, and this is a false positive, right? So this is the detection errors that I'm talking about. And another is called the localization error. So this basically means how much the overlap is between the ground truth and the predictions. So you can see here that there is a very less overlap, and this probably has a more localization error. You can also see from this graph, right? So this has more localization error, and this has very less localization error. The other important metrics that the clear mod uh, addresses is the association error, right? So the association error happens when the tracker assigns the same ID to two or more objects on the screen, right? So you can see here, I would also like to clear out these terms. The S meaning the hypothesis or the ground truth, and O means observation of the predictions. So here, the observation of the ground truth goes something like this, right? For the blue part, for the blue ones, and for the red ones, it goes something like the triangular ones goes something like this. So initially, S1 is assigned to O1, right? So here, S1 is assigned to O1 and it's working really good. But when I come here, the H1 is then assigned to H2. So there is a mismatch, right? Previously, this red dot, sorry, previously this blue dot, uh, sorry. Previously the red dot was assigned to the red triangle, but then on the next two frame, the red dot has been assigned to a different ground truth. And this is called a mismatch, and this is how we measure the association errors. So yeah, it basically means that the model failed to associate this instance with this instance, and it's giving me two different prediction for the same ground truth. And these are types of error that might occur in the MOT, right? So seen from the previous seen from the previous slide, we know that a good performance metric should be able to evaluate both these types of errors, and they should be able to determine the exact location of the object on the screen, right? So they should be able to determine the exact location, like in this 3 frame or in this like 4 frames for this green tracker. And it should be able to constantly track the object through the time. So it's basically referring to the association error that I just talked about. So a person one should always be given, a ID one, like in this example, this probably has a an association error kind of thing going on here, because the person is assigned 24 here, but on the next frame it is not assigned to anything because the object detection model failed to do that right here. And on the next frame it has been assigned to an ID 47. So yeah, this is kind of the thing that should be um, measured by the metrics that we use, right?
Siddhi, I have one question
Yeah,
over
sure.
here, right? Though I haven't that much in those sort of scenario, right? My concern is regarding, can you go to this types of error? Okay, let us imagine, all right, in human body, human face is most crucial information we can get to distinguish between two people, right? Are they same or different, right? But if you see the percentage, the human face cover, it is around 10% or something like that in total body, right? Which means that when we're calculating this detection or localization error, we assume that let us assume that it detected human body without the head, right? Right. At that time, I think it doesn't go and consider human head is something very crucial, right? Or we need to impose more if it miss human head, then we need to go and put more error on that. Those sort of things are not there, right? In training data set or whatever research we are doing right now. Giving more importance to the certain part of the body or segment while calculating the error. Do we have those sort of training data set, or do we have any measurement to go and calibrate those sort of error?
So, so basically that means the localization error. I think you're talking about the localization error. So,
But it's like it doesn't go and consider which one is more important body part or the segment. It consider, what does it do? It will go and consider all the segment has equal weight, right? It doesn't go and consider human face has more weight, hands and leg has more weight. If we miss hand and leg and we detect the human face, right? Okay, I'm fine with that. Do we have those sort of thing or not? Giving different weight for this body parts or the segment in the image.
okay, so so we're like more focused on the tracking as a whole, but not on the actual detection thing. So I think that is irrelevant in MOT.
Okay. Okay. Thanks.
Did I answer your question?
Yeah, I think it's like, yeah.
That would be more relevant if we were discussing about the actual object detection models. So yeah, I think that should be a separate topic for discussion.
Okay. Yeah, I think, yeah, I was just wondering whether we have those data set or not with the different weights for the different segment or not. Okay, I think you can go ahead. Yeah.
Okay, so I also wanted to share, the labeling thing that I was working on. So I think this might answer some of the question, right? So yeah, so the labeling that is done is something like this. So it doesn't give any importance to any part of the body, but it just gives, the
Okay.
importance to the whole human body or the whole bicycle, not the tires of the bicycle, but the whole bicycle. I think that's clear.
Yeah, that is my concern. My concern is that if the background has more area than the cycle itself while creating the rectangle, right? Though we find the overlap, right? It might go and miss information regarding bike.
Yeah,
because we are going and overlapping a lot of background thing. Okay, that
sure.
was my concern.
Thanks for the question, Shishidai. So I would like to discuss about the CLEAR MOT metrics finally. So it stands for classification of events, activities, and relationship. And it was introduced in 2006. The evaluation of multiple object tracking has its like a long history. It dates back to it dates back to the 80s, right? When there were military aircrafts with the tracking systems, and research has been going on since then. You can find research papers for those kind of trackers but they are not very relevant to what we are currently doing. But in early 2000s, there were like various groups of institutes that were really interested in evaluating these things, and they were working on a set of standard evaluation metrics. But such as there were few things like face and pets, but in 2006 there was a more standard evaluation metrics for the multiple object trackers. And this kind of evaluation and this multiple object tracker evaluation standard accommodates all the types of errors that we described on the previous slides. And it is also a very popular metrics, and it is a popular bench. It's a standard evaluation metrics for popular benchmarks such as MOT challenges and Kitty benchmarks. So if you don't know, MOT challenge and Kitty benchmarks are the places where you can send your multiple object tracker models so that they can evaluate it and then rank it. I think I should also show you some of the examples. Like for example, in this site, right, or in the next site, you can see there are like different people that are actually submitting their results on this site, and they're actually doing a benchmark on it. And I think that's kind of interesting, right? So this is this MOT, the CLEAR MOT metrics is a very standard evaluation metrics that are used by a lot of benchmarks. And I think we'll be talking about the MOT challenge benchmarks later on. So how does the CLEAR MOT metrics work, right? So there are two submetrics within the CLEAR MOT metrics. One is the multiple object tracker accuracy, and another one is the multiple object tracker precision. So the MOTA is a primary metric that takes detection and association errors into account, right? So how does it do? I have a formula that calculates MOTA, but I will not be going in depth to it. But I'll be just pointing out what it is accommodating: the false negative, the false positive, and the identity switch. So this is what measures the mismatch errors that we saw on the previous slides, right? And this is just the number of detections. So other metric is the secondary metric, and it's called the multiple object tracker precision, and it takes localization errors into account. This is a secondary metrics for MOT because we are interested in how well the object is tracked by the our model, and this is the secondary metrics because of that reason. So MOTP and MOTA satisfies both of the conditions for the good performance metrics that we just discussed here. So there are is CLEAR MOT the ultimate answer to the evaluations? Certainly not. It has various shortcomings, and some of which I would like to discuss in this slide. So
Siddhi, could you stop over? Could it be possible to go to the slide before? Okay. Here I can see IDSW mismatch error, right? Mismatch error is it's how do you do that?
So yeah, this one's quite interesting. So in this, right, there are two mismatches because the tracker for the I'll be explaining it for the H2 for the O2, right? So here there is one mismatch, right? Because the predictor just changes its hypothesis, right? And here it also does the same, right? So this is two mismatch errors. So that's how it's counted.
Okay, over the frame, if it is video of 1 minute, right, we'll go and calculate how many times there is mismatch.
Yeah.
Right, that will be the count. Okay, I got that. And could it be possible to go to the could it be possible to go to another slide? Okay, the same. No, the same one with the formula. Okay. Yes. Okay. And gate ID means number of detection, right?
Yeah.
It's like is it true or ground truth detection?
No, Yeah, it's all the detection in the ground truths.
Okay, it's like a no prediction detection. Though, if let us imagine if our algorithm went and detected the background as a human or something like that and gave the bounding box, then we don't go and count that.
Yeah, we just count the number of detection in the ground truth. Yeah.
Okay.
So these are the things that are given through the predictions: false positive, false negatives, and identity.
Okay. Then another quick question: what is the range of MOTA?
Range?
Yeah, range means the upper limit and the lower limit.
So the upper limit would be 100 and the lower limit would be 0.
Okay, it's like though you do 1 minus or 100 minus.
Yeah, so we do 1 minus, but after calculation, it's a ratio and we multiply it by 0 to 1. But it's for on the benchmarks you get on the sites that I showed you, you get from 0 to 100.
Okay, good. That is okay. I think that is why I think it will be better to go and explain to stakeholder, because it is a lot easier to express in percentage. Yep.
Yeah.
Siddhi, I would like to ask a question too.
Yeah, sure. Please go ahead.
The right hand side of the false positive and false negative, what are those?
So yeah, this is basically how we calculate false positive and false negative, right? So this the dotted line is the output from the tracker, right? So if you just see the left part of this picture, there is no person in it, right?
Yeah.
So the model is predicting something, but it's not there, right? So that's how we calculate the false positive. And on the right side, there is a person right here, right? But there is no bounding box over it. So that's a false negative. And I just wanted to show how false positive or false negative are counted.
Hi, Siddhi, can I follow up on this?
Yeah.
So I imagine a lot of time there's a little bit of an overlap and it's not this sort of binary separation. So how do is there a threshold you apply to make this distinction, or you know what I mean? If it overlaps just a little bit.
True.
Yeah, so there is some threshold that you can use and you can also play around with it, right? So in this picture, you see that there is no overlap, right? So the IOU is 0, but there is some overlap right here, right? So like some people would like to call it, a true positive, but some people would not like to call it that, right? Some people would just like to call it, there was some kind of error in the prediction, right? But most of the times there is some threshold that we use, and we can set that threshold to whatever value we like. But I would like to, personally, I like something from anything greater than 50% as a true positive.
Yeah, and I would also suggest that it depend upon what kind of problem you are solving, right? How critical it is to have more overlap, right? And based on that, I think you need to decide. It is something like if you are doing logistic regression, how to define this cutoff value, threshold value. It's almost same. It depends upon a domain or problem we are trying to solve.
Yeah.
Okay, Siddhi, I have one question here. So like you can have cases where like your prediction can be like 100% inside your ground truth, right? But it may not be the right person. You can imagine a video like a person is far, like quite far, but the bounding box, the entire bounding box may be inside. So imagine there are two persons. One is quite near to the camera, and the other is quite far. So the person at the far, who's quite far, will have a smaller bounding box compared to the one near. So you may have cases where like the bounding box of the person who is farther will be like 100%. So you'll have the IOU of 100%. So how do you handle such kind of cases? But that is this is clearly an error, right?
The both person are getting bounding boxes, right? And both person have the 100% bounding boxes. I mean, understanding it correctly.
Yeah.
So how is it an error? I'm getting it.
No. Just imagine like, so like let's say you have person one who's closer to the camera, person who's quite far from the camera, but like person two is like he's quite small, but he is so the person one's bounding box So he kind of falls inside the bounding box of the person 1 and 2. Like it's kind of, so person 1 kind of overlaps with both person 2 and 1.
Mhm.
So that means that the person 2's intersection with the person 1's bounding box intersection will
Okay,
be
yeah, yeah, I got you. I got it. So that's what this the ID means, right? So on the ground truth, there will be also an ID associated with this, right?
Mhm.
So that's how it's tracked, and that's how it knows this is the same person it was tracking. So you mean something like this, right? This case.
Yes, something like that. But like let's say
It's the same person.
there's another person, let's say behind this person 6, right? Who kind of is completely engulfed inside the bounding box of person 6. Let's say there is person 7 who's behind person,
Yeah.
and he appears quite small, which means now I think so. Now if you just consider the IOU, then the person behind this person 6 kind of has a 100% overlap. So
Amir, over the clear mode, can you go to that slide, Siddhi?
Which one?
And with the formula. Over here in MOT, everything is the cardinality count, not the intersection, right? So it doesn't care about IOU. It will just go and consider regarding the cardinality, whether it has, how many times it has false negative, false positive, or this mismatch error, or number of the ground truth we need to have. So I think that problem could be reflected over here, because we are not considering over regarding the area and those sort of things.
So what would be more interesting is that if this kind of thing happens and there is a switch between this, right? So consider this is a person 16 and this is a person 6, right? On the next frame, like it could happen that this person 6 is tracked as person 16 and this one is tracked as person 6, right? So that could be an interesting thing that could happen here. But as Shishadai said, these are the cardinality, the number of false positive, false negative, and identity switches, and it doesn't care about the IOUs after it has calculated the false positive and all these things.
And
also, basically, isn't what Amir is asking an occlusion issue that you were describing with the cars earlier? So it's a detection problem and not a tracking problem, right?
Yeah.
Yeah.
The car situation was similar, right? The big cars bounding box had small cars, and that's sort of, it's a detection issue.
Yeah, it's a detection issue.
I have a question, maybe with, I don't know if it's appropriate a little later, but is there any, do you have any thoughts on unsupervised methods for tracking? Because, there's, I actually work on a problem where it's like impossible to do all this labeling, and I imagine other people might also. So I actually have a video, but it's only practical to label few frames from this video. You're right? So do you have any thoughts on this? So I absolutely don't have any, association or anything like that across the entire video.
So you mean you could not label it because of occlusions? And
it's just too expensive to label.
That's one of my concerns as well, because I was also going to show you this kind of things, like for example, for labeling this thing, right? It's very easy, right? But if you want to label something that has like more cyclists, right, it would be very difficult and very time consuming and very expensive to label. So that's one of concerns that I was thinking about as well. So yeah, I too have that concerns. And
so one thing I can think of is just, like, for instance, some like a bicycle moving, right? A bicycle has to move in a smooth trajectory. And if there are like some weird jerks and, random, like, motion, I think that could be one, like, metric as well, to without any ground truth. But anyways, I don't want to get into this too much.
Yeah. So regarding our question, that's what most of our the clients is also hesitant about. He is like there are only very they only want to give the ground truth for the each image, but not the whole tracking, right? It's very expensive, and we've been asking them to do this, but they just want to stick with the detections right now because of
Yeah.
how time consuming and how expensive it is. That's another challenge that I faced on this evaluation. But I think there should be a lot of research on this, and a lot of research is still going on, right? So maybe that's an interesting idea
Yeah,
for research
thanks
as well.
for your comments.
Yeah, thanks. So yeah, this is also some shortcomings of MOT or any metrics that in general, right? So I'll just continue with this slide. So the shortcomings is that there is still no unified metrics, right? There are two metrics that I need to give to someone to make them understand, right? So that's still a problem. They're still not getting the accuracy that they're always talking about, right? And other like shortcomings is that it has overemphasis on detection over association, which basically means if we go into the slide, this only measures this mismatch, right? So it doesn't instance we see here, right? So this is not exactly the ground truth that is made for this prediction, right? But this one is counted as not error for the MOT, right? But seeing this, we should count it as an error, right? But for MOT, it just matches to the other ground truth and prediction, just like this. So it just calculates mismatch error, but it doesn't care that it was supposed to be other ground truth like this. So that's another shortcoming of MOT that I would like to point out. And it also assumes a single class, right, for MOT. So on multi-class, multi-object tracking, that's a different problem, which is overcome by HOTA, which is a higher order tracking accuracy metric. And it is a paper that has been proposed recently in 2020, and it basically takes all these shortcomings and just overcomes it, I guess. But this one is not used that widely, and even the most popular benchmarks like the Kitty benchmarks and the more challenged benchmarks, they just take in MOTA as the main metrics for the ranking, and they have still not considered HOTA as their primary metric. So that's why I'll only be discussing about the CLEAR MOT metrics. So for this demo, it will be a very short demo. I'll just be introducing like what I was doing and what I landed on while doing everything. So yeah, this is with something that is copied from the repository. So I'll just be cloning some repository that I was working on. And it's basically the repository that I worked from someone else's, and I just did some few editing on this repo. And there are a lot of repos that you could be working on, and I just found this repo to be, simple enough for me, and it was working well, very well.
Siddhi, quick question. Are you using this for the production?
No, not this one.
Okay. Yeah.
So on production, we have to So on production, we have to act not, we're not using the YOLO v4 on TensorFlow, we are using it on the TRT because we have to use it on mobile devices, and we have other models that we take into. This is just a very basic script.
And another question, let us imagine, right? You are supposed to calculate accuracy or error or anything, right? Yeah, and what will be the good approach? If you are provided with 1 hour video, right, and you need to compute the accuracy or error, right? You will go and divide that 1 hour video in 10 or 15 minutes video and compute all those things and average it, or how do you do? Or you will go and calculate everything in 1 hour video? What will be the process, the good approach?
I don't really know about the good approach, but what we get is very small video clips, and we calculate metrics for each videos.
Okay.
So yeah, I think dividing it into smaller chunks would be better approach, because I think it's later on.
Yeah, because if the video is longer, right, there will be chance that you might get association error more, right? If it is shorter, there will be less, because less video means there will be this chance that you will not have a mismatch problem, right? And so that the thing will be there, right? And I was wondering what might be the good approach while calibrating those thing.
So when we were actually working on the production with on a very smaller device, running a very long video, we were running into some issues on crashing because we were also saving the videos, right? So, and that's a problem. That was a problem, and we were evaluating only on very smaller video clips, and those video clips were taken with a motion sensor. So only when there was some motion, we would be capturing the videos. So I don't think I have to install any dependencies. So what we are doing is basically we are using the darknet version of the YOLO, right? So we're just downloading the darknet version of the YOLO. And for this, there is also a conversion script that we can use so that it can be imported into TensorFlow. But on production, I think you might want to go with TF-Lite or TRT, because running both the TipSort and YOLO v4 might be not good for your hardware. I was running into all sort of hitting issues on my Jetson Nano.
Siddhi, I was just curious about, like you said, you kind of work with the mobile devices, right? So
Yeah.
So you'll have like very limited resources that you can use for
exactly. Yeah.
No, can you share about the challenges that you have faced when you try to like convert your models into like TensorRT and such?
Yeah, so converting to TensorRT is not really straightforward, right? It does require some really specific hardware as well. And yeah, when I was using my Ubuntu 20, like it was not allowing me to install TensorTRT on Ubuntu 20, and I had to basically downgrade to Ubuntu 18. And even though I was downgrading to Ubuntu 18, I was not able to convert everything to TensorRT. Just all sort of dependencies issues, right? So what I would recommend is just use a cloud service, or if you have a better version of the Jetson Nano, or the better version of the hardware that you're using, I recommend you converting those models on that hardware itself, because those hardware for the Jetson Nano, it came pre-installed with the TensorRT itself. So yeah, but if you are using TF-Lite, I don't recommend it using on the Jetson Nano, because TF-Lite is not optimized for NVIDIA. TensorRT is.
Okay. Yeah. Yeah, actually, because I also have some experience of working on like similar devices like Jetson TX2 and Nano.
Yeah. I think
years.
TF2 might be able to do these things, but I'm not sure with Jetson Nano. The Jetson Nano could not even load the yellow model. It was just loading yellow tiny, but it was not doing any predictions.
So, so how do you find the performance differences between using it on like Jetson Nano, the performance difference? Because I'm sure like you have to kind of downgrade the precision of your model as well, right?
Yeah, so since we're using the lighter models, right? And we're also not being able to load the deep sort model on the Jetson Nano, and we're just using the basic tracker, right? With no tracker, basically with no tracker.
I
Right.
should have a pain on this actually. I also
So that's how we're working on it.
On that note, Amir, I'm not sure did you miss or not. The first session or first webinar was regarding model compression and quantization, right? And there, Vivek has presented his idea how we can compress the model, and we can compress the model to get relevant amount of the accuracy on device, right? So I think it is in YouTube. You can find that easily, and you can go through that. And if you have any problem, you can share your problem in Slack, and Vivek might answer your problem. It will be useful for you.
okay, sure. Thank you. That'd be great.
Yeah.
Yeah.
And Vivek currently is in South Korea and is doing his research or work regarding this tiny or model compression or something like that. Tiny models.
Wow. Okay, that's great. Thank you, Shishir.
Thanks for the question, Amit. So I'm just trying to convert the dark net width into TensorFlow model, and for me on the production, I just use the converted models. I tend to store these converted models in S3 and just pull them to the mobile devices with some basic model pulling and management type of scripts. I kind of agree with the comments that someone made earlier about how expensive the labeling is, right? And it shows on the demo as well, because I'm not labeling anything. I'm just taking the data that is labeled by someone else. I'm just running the tracker to just show like how you can get to the predictions for evaluation. So the model has been converted, right? And then I'll be running YOLO with deep sort, right? Deep sort is also a pretty good tracker, and it goes well with YOLO as well. And you can try different sorts of tracker and different sorts of models. I'll be using whatever comes default with this. So yeah. So if you see later on, it's not giving me the frame rate that I want right now. And on Jetson device with on mobile devices with the TensorRT, I'm getting like at least around 19 FPS. If I just run the YOLO before model, right? But if I try to run the deep sort on it, it's not even loading two models at once. I'm not sure like why that's problems happening, but yeah. But on the triple app, it's not a problem, but I'm not getting the frame rate that I want. And I'm not converting it to TensorRT right now. Maybe that requires, maybe that can be covered in the future sessions. So yeah, so this video is not that long, but it's taking really long because I'm not even getting the frame rate that I want. I'd be happy with like at least 15, but it's only giving me like 3 to 4. and I'm not happy with it. But on production, like it's really unacceptable, because we need to have something going on a real time. So one way to overcome this would be to skip frames, right? So that was one of my first approaches on doing it. We don't even need that much of frames, so I just skip like 9-10 frames, and it works a bit faster. But later on, I don't think that might be a very good solution. So I just focus more on quantization of the models and running it on the TRT.
Siddhi, how long is your video?
It's not that long. It's like
how many frames?
It's not that long, but it's going to be over soon. Yeah, it's soon. It's over. So since like Jupyter Colab cannot load the video on this, I'll just run something else to display it on the Colab.
Siddhi, what kind of tool do we use for labeling this sort of thing?
So yeah, tool
Because
that
for image, we have Coco annotator and those sort of things, but for the video, for each
for
frame,
the video, I was using this one for my manual evaluation testing, right? So this is pretty good tool, and if you want to you can label it using some pre-existing model as well. So it will just label it for you, and just have to correct some of the labels, right? That so that you don't have to manually label each frame. So that's how it works. So, and if I want to export it, it's easy
and
as
this is
well.
open source, right?
Yeah, this website is open source, and you can host on your laptop as well.
Okay, I can make it local host and run in my laptop.
Yeah, you can run it on a local host as well.
And do they have any hardware configuration, like it need to be in GPU or something like that?
No, it doesn't need to be in. It doesn't need to be in GPU, but if you have GPU, you can work on the automated tracker that I just mentioned. You can just use some pre-existing model to label it automatically and just correct it on some instances.
Yes, that is what I was looking for, this one.
So you can also
automatic labeling could be done in CPU or in net GPU. That was my main concern.
You can do it on both, but I recommend it on doing it on GPU, but it's really very slow on the CPU. And so you can also export these annotation on various formats, right?
Okay,
so the thing I was talking about is MOT, right? So you can also export it on MOT format and just send your ground truth and the prediction to the MOT challenge benchmark, and you can if you have your custom if you manage to make a custom tracker, you can just send them to here, and you'll be on the leaderboards.
Nearpress Parazul, I think you mentioned some problem regarding labeling the data, right? Have you tried the same platform what Siddhi has mentioned? Because it has already inbuilt model which will give you first version of labeling, right? If you are not satisfied, you can go and further label it, right? But while building a prototype, you can start with whatever it has given you, and you can go and you can try it, and whether you can validate your idea with that, and you can create the POC. Have you tried this one platform, CBAT?
Yeah, I have not tried this particular one, but I've used similar platforms for labeling. But still, the challenge remains, particularly because the problem I'm working with, it's not. Actually, in a lot of cases, requires experts to label, because I'm working on medical data. So I can't. I'm not. Even if I could, there are regulations where You can't
Yeah,
have like normal people labeling. So that's why it gets extra expensive, because now you have to ask doctors or other trained medical professionals to do this. So it's like 10 times more expensive.
yeah.
Yeah, so it's a problem.
Yeah, that is not only the problem for the video. Even that is the problem for a simple image sort of thing, right? Having those sort of export to label the data is far expensive, right? So it's a big problem if we want doctor or engineer or some.
Yeah, and another issue in medical images is we rarely do bounding box segmentation. We in fact oftentimes do, contour based semantic segmentation, because the boundaries are, much more. It's not like, you can imagine,
That is what I was asking with the Siddhi first. If we have the contour based, right, we can get some sort of probability distribution where is your focal point is, right? And based on that, you will start to give more importance to certain section and less importance to the other part, and you can start to go and do those sort of thing. Yeah, I think contours sort of thing will start to solve those sort of problems.
But for us, like we just give it to some labeling companies and they do it for us. So that's easier for us. We don't need expert to label people. I think in your case, that might be some very great challenge for you. And still, doing this labeling, it's expensive for us. And I can
because for that one short video you have you have around 200 or 300 frames, and you need to go and label each frame, and it will just imagine how expensive it will be.
Quick question though, usually you would need the full video annotation only to build evaluation data, right, and test data, because for training it doesn't, you don't care that much. You can just do, you don't have to label all the frames for training, because the model at the end of the day is still a frame level model. It's not a video, it's not a 3D model, right?
Yeah, so we have like different trackers we use, right? For detection we are using YOLO, so we don't even care about
for the tracker you do need them. Okay, never mind.
But if you're using basic tracker, then you don't care about anything.
Again, it depends, right? If you are using existing model and if you evaluate with your level test data set, and you got some sort of if you got a good performance, I will not say the accuracy, but based on your acceptance criteria, then I think you can go with the pre-existing weights or something like that. At that time, you don't need training data. Again, it depends upon your domain, what kind of thing you are working, but I afraid that it will be very difficult in health sector.
In my case, like the evaluation is important, but they are not really interested on retraining. They're just interested on using the pre-trained models, because training is expensive as well. You still have to label a ton of data, and if the existing models are working pretty well, then we don't need any extra effort for that. That's how we're working currently.
I think I think we need to go with this collab now.
Yeah, so this is how basically works. It was giving me like 3 to 4 frames per second, but on the output video it's giving me decent FPS. This is what I expect ideally the tracker will be doing on the real time. It's a bit slower on what I'm running currently on my mobile device, but
can you play the full video?
Full video from start to end? Yeah, sure.
Yeah. Can you stop over there? When you have the box over there, I don't know, that is bin or something like that, it was detected for a fraction of a second.
Bin, this one?
Yeah, it was detected for a fraction of the second. No,
maybe.
Can you go from beginning?
Yeah.
Okay, yeah, right. Then in this case, right, what will be your error count?
Error
for whole
count?
Video? Association error count, because it will be 1, or we'll go and calculate in each frame.
So the the IDSW, right? So we're talking about that, right?
Yeah.
So if it's like assigned to a different suitcase, like 48 or 49 something, it's 46 right now. So if it's assigned to 48 on the other frame, it's gonna be an association error right there.
Yeah, and it will be one, or it's like it is over there from beginning of the video, right?
Yeah.
It is not moving, which means that it should be detected from the beginning of the video, right? Which
Yeah.
means that it means some sort of association from or something like that. Which means that for each frame, it need to be counted as error, right? And this 48, it will be something that it is detected correctly, and again it will be error. How it will go and
So,
calculate
yeah.
sort of thing.
So for the association error, right? If it's not changing its ID, then there is no error. That's how
But the thing is that in first frame, there was no ID. It is
Yeah.
there from the beginning of the video.
Mhm. So it's going to be a detection error. So if you are in your ground truth, if you have the suitcase over here for all the frame,
Mhm.
so it's
Mhm.
going to be a detection error, but not the association error. If you are thinking about the association error, then it should, for a brief second, it should be like suitcase number 25 and then suitcase number 48. Then there is one association error. But if you are talking about error, it would be on the detection error.
Okay.
So you can see that this bicycle is, being labeled as 35 throughout the video. So there won't be any detection. So there won't be any association error, but there will be detection error.
Okay. Yeah, I got it.
I hope I'm clear on that. So in this script, so I'd like to show you like what kind of data format that the mod challenge is taking, right? So this is the kind of data format that mod challenge is taking. And this is basically the bounding boxes information and the frame and the class name, right? Since MOT doesn't care about the class name, we'll just since it's just based on the single class, right? So this doesn't even matter right now. For the mode evaluation, I'll be including a different repository, and I will be downloading a different, a zip file and extracting them. I'll also be showing you how these data look. So, if you want someday, you can just send the mod challenge benchmark your own data sets. For us, we didn't use this exact code. We just took motivations from it. And for the evaluation, we're not even sure if we want to evaluate the whole MOT, because the client is really hesitant on the cost that they have to bear for labeling those things, and they're just hoping that if we have a very good object detection, it will yield a very good object tracker as well. It will give us a very good tracker algorithm as well. So that's where we're kind of stuck right now. And that's what I was, I wanted to address with this presentation as well. Like, we know it's important, but no one is doing it because, of all these challenges that, we discussed earlier as well. And yeah, I think there needs to be some, more research on how to do it more effectively. So for the track eval, yeah, so the data should be like this: the ground truths and the trackers, right? So on ground truths, there are like different benchmarks. So since we're focusing in the mod challenge, we'll be going inside this, and these are the folders that contains different video sequence files, right? So let me go to the mod 17 twin file, and there are these folders over here again. And if you see inside these folders, there is the ground truths, right? So this is the ground truth for this specific video file. There is a video file named MOT02 DPM somewhere. So this is the same format, right? And for the tracker, that the our tracker produces, we'll have to put it in this format, and it's a bit simpler than the ground truth that we have to put in. So for this, there is something right here, right? So this is what we'll be looking at. This is the actual prediction that is done by the model, and this is the ground truth for each model. And there were like really motivated people that labeled this. I'll not be able to do it myself. I was really frustrated. So to run the evaluation, you just have to point it to this script and the benchmark that we're using, right? So we're using the mod 17. That means this data was probably gathered around 2017 for the mod benchmark. And these are the standard set of benchmark videos that if you someday make your own trackers, you can just test them on this. You can just they're already ground truths here, and you just have to produce these tracker outputs, and you can just compile them. I mean, you can just run them yourself or send them to the mod challenge. So there is which split to evaluate. So this is the training set, right? If you have testing and other kind of thing, but currently it doesn't matter. We're just using the evaluation on the 2017 data set, right? So other parameter is that the metrics, which metrics do we want to use? And for now, we'll be using the CLEAR MOT, and there are also other metrics that are available, like MOTA, IDF1, and base, and other things. And this other others for performance and things. If I run this script, then you'll be getting some outputs.
So actually, I was curious, what is the what is the output of the tracking, right? So you have prediction of all these objects for each frame, and the tracker has to basically solve some association problem through the entire video, right?
I didn't quite get you. Can you?
So basically, I understand what is the, so to me, what the output of the detection is clear. So it's just for every frame, there's a list of objects and it's bounding boxes, right?
Yeah.
But what is the output of the tracking? Precisely, because you're showing you can compare these two documents. So I was just like not sure what is the content of this document. And is it for every object, its position through the entire sequence, or what is it? What is it that you're checking?
And I think the ground truth has ID for the each object, right?
Yeah.
And it will be same for the prediction also. We are not looking only for the whether it is man or human or a bicycle, right? Each human has its own ID, each bicycle has its own ID, and based on that we'll go and calculate association, and that is there in the ground truth also and in the prediction also.
Yeah, so the ID, right? The ID that I showed.
Siddhi, could you quickly go to this collab video, the one you had? Could you go to the video? Yeah, could you play it again? I think you can see ID, right?
Yeah, this ID.
Yeah, this is unique identifier for that object, and it need to be fixed within the whole frame, right? If this bicycle 16 is assigned as a bicycle 17 in 20th frame, right? Then that will be started as a association error or something like that.
Got it. Yeah. So it's basically that's my answer to my question is, it's this process of assigning the ID that is exactly what is the tracking is, right?
Yes, that is how we will go and calculate whether we have the relationship between the each detection or not. Because we need to have this linear relationship between each object, right, when they are moving. To get that, we will have this identifier ID over there for each object.
Yeah, so this ID is the ID that is given by the tracker. for
Mhm.
so this is the format that I was talking about, right? And this is the ID that is assigned by the tracker, or in case of the tracker, and in case of the ground truth, this is the ID that is assigned by the manual, the person who manually labels these videos.
What are the last three points, the X, Y, Z?
And these are the coordinates for 3D video. So these are for 3Ds, and for 2Ds, this can be ignored.
Okay.
And we can just place -1 for all of them.
Okay.
And even for the, it doesn't care about the conference. The mod doesn't care about the conference as well. So yeah, after
Yeah, Siddhi, I think we need to wrap up now, right?
okay,
So,
sure.
yeah.
So these are kind of the and the metrics that we're getting for different videos, and these different videos might be on different environments, and we can test like how well our videos are doing on different environments, right? For example, this is doing really well on this kind of video files, but not on this video files. So as an evaluator, I'll just go and check this video file and see like what was actually wrong with it, so that I can, if needed, I can retrain it on similar data sets for the detector as well as the tracker. So I think, yeah, we're wrapping up, and if there are any other questions.
Yes, and last note, if you have any question right after this presentation or tomorrow, please feel free to drop your concern or your question in Slack, and Siddhi will be there, and if he can help you to solve your problem. He can give you guidance. I'm not sure he will give, you will go and solve your problem, but he will give the idea or guidance to solve your problem. Yeah. If there is any question from any community member over here.
Hi, I have one question. So thank you, Siddhi, for this wonderful presentation.
Jeevan, before asking question, could you introduce yourself? Where do you work, and what is your name? So the other member.
Sure, okay. So I'm Jeevan. I have been working as a machine learning engineer at Fuse Machines. I did my bachelor's from Pulsar campus.
Yeah, I think we don't have to go. We don't have to go. Just your name and the company you associate with. Yeah, I think that's fine.
Okay.
Yeah.
So coming to the question, so I guess for the deep set model, there is one particular part where we train this re-identification model. So Siddhi, can you please share some of your caveats while training the model, like what was the batch size or something like that? Because for this re-identification task, I believe that these things do mainly intrigue the training process. So do you have any caveats regarding those?
Yeah, currently we are not really interested on training the models ourselves, because it is very expensive for us. So yeah, I don't have hands-on experience with retraining and training for these kind of models.
Okay, thanks. And what about some of the thresholds that you were talking about, like maybe there is some NMS threshold and other things for the object detection itself, and also maybe I think there should be some thresholds for tracking. So do you have any caveats on those? Like how do you tune those thresholds and those parameters?
So yeah, we need to have the evaluations going on for tuning the thresholds, right? Since we do not have very big sample of the threshold, I mean very big samples of the video files that we are getting from our clients, so right, so we are not being able to experiment with it as like we're experimenting with the mock data sets, right? So we're just playing around with we're just using our tracker model to just play around with the mock benchmark data sets, and we're not very effectively playing around with the actual data sets that we're getting. So I think I would really like to play around with the thresholds and all those stuff, but unfortunately it's just that the opportunity hasn't arrived yet from me.
Okay, thank you. And I have one last question. So I'm kind of interested for a re-identification problem where people can so let's take away the problem of changing clothes, but where a person wearing the same cloth might be aligned at different poses. Let's say he might be sleeping on his bed or on the couch or cycling or moving straight. So do you know of any data set where this type of problems have been involved? Let's say for the Mars itself, I think the image size is like 256 by 128 or so, inferring that the people need to be straight up. So do you know of any data set where people might be inclined in different poses or others?
Most data set that I looked into were, just people walking around and there weren't even like, very large number of classes that I, worked around that I was working with. And from my personal experience, I only work with bicycles, cyclists, all those kind of things. So I'm not really familiar with those kind of data sets that you're talking about. It is very difficult to find the label data sets for such kind of problems.
Yeah, indeed.
I feel
Yeah. Okay, thank you. Thank you.
Yeah.
Thank you.
Do we have any question? Seems like we don't have any, right? Now, I think we're end of this webinar. Thank you, Siddhi, for a wonderful talk. It was mind-blowing, or it was eye-opening for me. There was some of the things which was really interested, right? And thank you all the community member who participated, right? And yeah, thank you everyone.